Okay, so this is assignment 2. I think number 7 is where we'll start. It does say solve, so that does mean that you should factor. Um, this is a complex trinomial and you can factor it. But what's different is that it's an inequality and there's a greater than sign here instead of an equal sign. So if I look at lesson 5, what that means is when we look at a function and if we look at a parabola that's opening up, where this function is greater than 0 is anywhere from the x-axis up, and where the parabola is less than 0 is anywhere from the x-axis down. So if we were asked, where is this parabola, where is this function greater than 0, it would be this side here, the x values for that part of the parabola, and the x values for this side of the parabola over here. If we were asked for where this function is less than 0, it would be these x values in here that are at the bottom. So the x values would be in between 1 and 3 if it was less than 0. But if this function is greater than 0, it's any x values that are over on this side and any x values that are over on this side. So it's a very different question if you're asked for something that is greater than, a function that's greater than or less than. When it's greater than, we have these two answers. The x values where this function is greater than 0 are anything less than 1, because it's all of these values and they go on forever, and anything greater than 3. So that's why it's written in 2 steps here. If we're asked for where is this function less than 0 vertically, it's these values here, but they're in between 1 and 3. So the answer where it's less than would be x is in between 1 and 3, and that's the way you'd write those questions. So it's always written the same way. Your question is either going to be greater than or equal to, or less than or equal to. So this one is a little... Okay, let's look at this one. This one from lesson 5 is a complex trinomial, which we did by trial and error, and we have is less than or equal to. So less than or equal to would be these values here, those x values. That parabola there is less than vertically. The y values are less than 0 for anything in between 4/3 and 5/2. So that's why x is in between 4/3 and 5/2. If we were asked for a greater than question, which I think is like the one on your assignment, greater than means these values on the right and the left. So if our intercepts, when we actually factor, we get the intercepts, we would say this would be in 2 steps here. Our values for x are anything less than 5 or greater than 1. Okay, if we look at number 8 from the assignment, number 8, the nature of the roots. So we can figure out the nature of the roots just by calculating the discriminant. So this is like lesson 7. Lesson 7, we have to remember that we have 3 different options. You might have no real roots and the parabola is up above or down below the x-axis. We would then go ahead and calculate the non-real or the complex roots for that function. You might just have one root and we can call that a double root. But if the parabola actually just touches the x-axis and that is the vertex, we would say that we have 2 equal real roots or 1 double root, but it just means it only touches once. And here is the most common. We have 2 distinct real roots. So those are the 3 things that can happen. If we look at just what is under the square root sign, that's called the discriminant. b squared minus 4ac, just that part. If that's positive, and we get an answer like 25 or 6, we're going to be able to find the square root and we're going to be able to continue that question and we'd be able to find 2 x-intercepts. So it would look something like this one. If we get an answer underneath here that is 0, then we'll just be able to take these two values and divide them, and we'll get a double root. It'll look like this. But if underneath the square root sign we get something that is less than 0, like the square root of -9, the square root of a negative number, then we know that there aren't any real roots, but we would go ahead and find the non-real roots for that. So the one that you have on your assignment, you have an A and a B, but you don't have a C, so the C would be 0. All we need to do for the discriminant is just use this part, b squared minus 4ac. We sub in our A, B, and a C, and in the one on the assignment, this part would actually be 0. So this entire part would cancel out, and we would just have a value here. So if you get a positive number, we would have this answer. We would say, oh, since this number is bigger than 0, we must have two distinct roots. Two distinct real roots. We're not trying to find out what they are right now. We're just trying to find out how many there would be. The second one from lesson 7, when I go ahead and do this and I sub in these values, I got 0. So that means we would have a double root or two equal roots. It would look like this one up here. And this one, when I sub in the values here, I got a negative number. So that means we would have two distinct non-real roots. So really that parabola would look something like this one. So that's number 8. Number 9 on the assignment is something still on the same example. It's something like this one. So again, we're just using the discriminant. So number 9 on the assignment has two distinct complex roots. What value does k have? So we would start it out just like this, number 9, and we're just going to sub in our A, our B, and our C. So if you have an unknown value, we would sub that in. I think in the assignment it's the B, no, it's the A that you don't know. So the A value you don't know would be in here. You go ahead and just solve for that letter. So I sub in the A, the B, and the C, and I go ahead and pretend almost like this is just an equal sign, and I try and get that letter alone. So that's what we were doing here. The only thing you have to be careful of with questions like that, if I have to move something over the equal sign, that's fine, or over the inequality sign. But if you have to end up dividing or multiplying by a negative at any time, you divide or multiply by a negative number, this sign would change direction. So that's the only thing you have to remember for number 9. Number 10 is like lesson 8, example 2. So lesson 8, it's completing the square. So you end up with something that looks almost exactly like this. This is example 2 from lesson 8. If you only have 2 terms and then you go to complete the square, you take half of this 8 and then square it. So half of 8 is 4, 4 times 4 is 16, add 16 and take 16 away. So we are trying to complete the square to find the vertex, because this gives us our x value and this is our y value. What this question on the assignment is looking for is just what this x value is. So if I look at number 10 on the assignment, can I make some notes here? Number 10 on the assignment is really important that you start out with Fred and Barney. So Fred and Barney have $50. You have to notice that then if I wanted to get Fred or Barney, if I want to isolate the F or the B, it doesn't matter which one. I could do Fred. Let's do Barney is 50 minus Fred, the F. So if I got this B alone, I would move the F to the other side. So that would be what Barney equals. So if I was going to say that those two together, if F is Fred and 50 minus f is Barney. So now I have an f for Fred and a 50 minus f for Barney. I can now look at the product of those. So it says, what is the product that would give a maximum? So maximum is vertex. The product of those, so I have f and I have 50 minus f. That's Barney. So I do have the product of those two people, of the amount of money that they have. If I expand that, I would have 50f minus f, and I can't really make a squared, but that's minus f squared. Well, I don't like that, how that looks, so I might write that as negative f, I'm just going to rearrange it, squared plus 50f. But we can't complete the square if there's anything in front, so we divide by a negative number, negative 1, we would have f squared minus 50f. And now the trick is to go back to that example and complete the square with f squared minus 50f. Take half of 50, which is 25, square it, add that number and take it away, factor, so we have to complete the square from there down to finish that question. And then the x value of whatever you get is your answer. Because it's a maximum, we're trying to complete the square to find the vertex. Last one, number 11. This one's not so bad. It's just area is length times width. So this is where when we solve word problems and we're solving for x, we factor or use the quadratic formula. So this one, if we want to take, we know that the area is 28 of it's just a rectangle. And we know that the length is 3 meters more than the width. So the area we know is length times width. We know the area is 28. And then the length is 3 meters more than the width. So the length could be the width, or let's make it x, plus 3. And that means the width is just x. So if x is the width and the length is 3 meters more than that, length times width equals 28. Remember that you always have to get all of your terms on one side. So we'd have x squared plus 3x minus 28. And all you need to do now is factor this. So when we factor, that's just a simple trinomial. We would get two values. If one of them's negative, you can't have a negative length, or width. So you'd choose the positive answer and that would give you the width. But then you'd have to also notice that the length is 3 meters more than that. So you'd have to also state what the length is when you're done. But that one's really quick to finish.